All right, slope and direct variation. Let's go. Direct variation is an equation in the form y equals kx, where k can't be 0. So as long as that's not 0, you're good. That's what direct variation is always referring to. So if you get a word problem that says, what is the direct variation of? It means it's this form. This equation is what they're referring to. Now the constant of that variation is in that equation, y equals kx, k is considered the constant. You could almost think of it as constant spelled wrong, if you really wanted to do something interesting. So that's how I remember that the k is for constant. A family of graphs includes graphs and equations of graphs that have at least one characteristic in common. Could be their slope, could be their intersection point. So there's just several of them on one. There'll be several lines on one graph is what that's really kind of saying. A parent graph is the simplest graph in that bunch of lines on one graph. Or on, yeah, a bunch of slopes and a bunch of lines on one graph. All right, direct variation graphs. So direct variation are equations that are in the form of y equals kx, where k is not equal to 0. We already said that. So the graph of kx always passes through the origin. That's because there's no plus on there. So you remember y equals mx plus b. There's no plus b. So that's why it always passes through the origin. The slope of k is positive if k is bigger than 0. If it's a negative, it's less than 0. So it's the same as a slope. That's kind of what you want to think of this as. All right, name the constant of variation for the equation, then find the slope of line that passes through that pair of points. 2 points. Well, we know how to find the slope. We did that yesterday. So first we're going to use that slope formula that we had yesterday. And I would probably label those all out. I'd label them over here. They did it off to the side, which is fine. You can do that too. So 2, y2 minus y1 over x1 minus y1 comes out to 2 over 1, which goes to 2. So there's what my slope is. So that would be also my k. So the constant of variation, remember constant, you can think of constant with a k. Constant of variation is 2, so therefore the slope is 2. So again, name the constant of variation for this equation and find the slope of the line that passes through the pair of points. The nice part about this one is they're giving you 0, 0 at the origin for one of your points. All right, so here we use the slope formula again. We're going to label them out, put them in. So y2 minus y1, x2 minus y1. You notice they're using y1 as your 0, 0, so it stays the same. So that gives me a slope of negative 4. So that means the constant of variation is negative 4, and the slope is negative 4. If you were paying attention, it was right here too in the picture. All right, name the constant of variation for the equation, and then find the slope. Okay, so we can use our formula. I'm going to call this x, or this is going to be 1, this is going to be 2. So 4 minus 0, 1 minus 0 equals 4 over 1, or 4. And so my slope is 4, my constant is 4, which is in here. So 4 and 4. All right, again, name the constant of variation and then find the slope. So you do have to have 2 answers on these when you get to your homework. So I'm going to call this 1, or sorry, this one's going to be 2, this is going to be 1. So negative 3 minus 0 over 1 minus 0 equals negative 3. So, and then my constant is negative 3 over here in the picture. So negative 3, negative 3. All right, graphing a direct variation. So graph y equals x. So we write down the slope as a ratio. It was our first step. So that's going to be rise over run. We graph from 0, 0, because everything for direct variation starts at the origin. We're going to draw a point going up 1 and then 1 to the right. They have them here, up 1, over 1, make another dot. And we're going to draw connecting dots through that. Okay, so now we're going to make it a little more difficult. So y equals negative 3 over 2x. So again, we're going to start these as a ratio, write the slope as a ratio. So negative 2 over, so rise over run, negative 3 over 2. We're going to start at 0, 0. We're going to go down or up if the rise is negative. Correct, down. So we're going to move 3 units down, 1, 2, 3 units down, and 2 units to the right, and draw our dot. Draw a line connecting those points. All right, your turn, go. All right, so we're going to figure out what this slope is. So 2 equals 2 over 1. So rise over run. So I know it's also positive, so I know it's going to go in a general that direction. Let's just make sure, is it going sideways or is it going more up? So it's not this one, it's not this one. So rise would be up 2 over 1. So I think it's B because it's not up 2 over 1, correct. B is it. All right, try this one. Okay, a little more difficult here. So we're going to first express this as a ratio. So negative 2/3 is the same as negative 2 over 3. And we want the negative to be on top because that determines up and down. So if I start at the origin and I go down 2 over 3, it's going to go in a general that direction. So down 2 over 3, that looks like the correct one. Nope, that's only going partial. Bam. All right, so write and solve a direct variation equation. Suppose y varies directly as x. So this is where they're going to say varies directly. That means you're going to see y equals kx in here somewhere. When y is 9 and x is negative 3, write a direct variation equation that relates x and y. So first we got to find the value of k. Well, they've given us x and y. So we use the direct variation formula. We insert x and y for each of those points, substitute in for 9 and negative 3 in for y and x. May have said that backwards. Oh well, keep going. We're going to divide both sides by 3, which will come out to a negative 3 would be k. So therefore I can say a direct variation equation is negative 3, y equals negative 3x. I'll bounce back here. So because this is here, I can take this original formula and go y equals negative 3x. That's how we get this into here. So we're just substituting that in for k in the original direct variation equation. All right, use direct variation to find an equation to find x when y equals 15. Okay, and this is going off of the one from before. So we take that negative 3 number that we had from earlier. So that's our direct variation equation for this problem. So we just substitute in y for 15. We divide by negative 3. X comes out to negative 5. So therefore, x is negative 5 when y is 15. All right, try this one, go. All right, suppose this area when y is 15 and x is 5. So I'm going to take my direct variation equation. I'm going to substitute in 15, and then k is going to be 5. We'll just leave it like that. Divide by 5, divide by 5, comes out to 3 equals k. So then I can write it as y equals 3x. Okay, and the next one's going to relate to that. Suppose y varies directly. Now y is 15, x is this. Use the direct variation equation to find x when y is 14. So we're going to take the equation from the last one, which was positive 3, y equals 3x. So we're going to use that right here, y equals 3x. And we're going to do substitute in negative 45 here, equals 3x. We're going to divide by 3, divide by 3. Punch that into my calculator, negative 15 equals x. All right, the Ramirez family is driving across country on vacation. They drove 330 miles in 5.5 hours. You know, we're going to say it's a constant. No Starbucks stops here. Write a direct variation equation to find the distance driven for any number of hours. Keyword here is any and direct variation. So we're going to put this in a word. Distance equals rate times time, because we're asking for distance and time here. So let R be the rate. We put that in here. The miles total, distance, 330, equals rate. So that's the one we don't have, times time of 5.5 hours. Solve that for rate. 330 equals R, divide both 5 by 5.5. 60 equals R. So therefore we can say the direct variation equation would be D equals 60T, because we're using that distance equals rate times time. Note to self, it looks exactly like direct variation. There might be a reason for that. Graph the equation. So graph of D equals T, 60T passes through the origin and through with a slope of 60. So we turn that into rise over run. So 60 over 1. So it would look something like this. The hardest part about this would be actually figuring out what numbers to use, and then for hours. I may have done it in 50s. They did it in hundreds. It actually doesn't matter. It's just however you label them. All right, estimate how many hours it would take to drive 600 miles. So we take the equation that we came up with in part A. We're going to substitute in 600 for D. And then we're going to divide both sides by 60, which comes out with a time of 10. So that would be 10 hours. It'd take 10 hours to drive 600 miles, plus Starbucks and bathroom stops. Pause this, give it a shot. All right, Dustin ran a 26-mile marathon in 3.25 hours. Random side note, Berlin just had a new world record of like 2 hours and something minutes. It was crazy. Almost a sub 2 hours. Moving on. Write a direct variation equation to find the distance run for any number of hours. So I'm going to use distance equals rate times time. We need to find the rate. My distance is 26 equals R, and then time is 3.25. Divide both sides by 3.25. And that comes out to 8. 8 equals R, so then I'd rewrite my equation. D equals 8H. So remember that number because we're going to need to keep using it. Moving on. All right, so Justin ran a marathon of 3.25 hours. Graph that. So we know my rate is going up by 8 each time. So up 8 over 1, up 8 over 1. So it means it's not constant. That looks like it's going only up like 2. That's going up by 5. That one went up 8, so C. All right, how many hours would it take to jog 16 hours? Go. All right, so using our D equals 8H, we want to go 16 miles in 8. We'll divide by 8, divide by 8. I'm sure you can already see it. 2 equals hours. That's all she wrote. See you in class.